The group's first step was to design a preamp. A preamp is needed to increase the input signal, in this case a microphone signal, to the line level strength required by the load, or in our case the power amp. It does this by providing stable gain while preventing induced noise that would otherwise distort the signal. This is accomplished by using a common source amplifier tied to a common emitter amplifier with appropriate biasing circuitry. The most important characteristics of the preamp are high input impedance and a good frequency response. High input impedance is accomplished using a field effect transistor, and a good frequency response is obtained using a bipolar junction transistor. This is the group's design preamp schematic. The value of RG was chosen to be high, 1 megaohms, to keep the input impedance high while preventing the input from floating if no signal is connected. To facilitate the design of the preamp, reasonable bias points needed to be chosen. The operating points shown in Table 1 were selected. The VC and VE values were chosen to center the preamp output between VCC and ground and to allow the maximum possible voltage swing. IC and in turn IE were chosen such that the preamp could provide enough current to drive the power amp. This allows the rest of the components to be calculated. The calculation for the emitter resistor is shown in equation 1. The collector resistance is calculated similarly as shown in equation 2. These values were chosen to center the output of the preamplifier at 15 volts or 1/2 of VCC and satisfy the biasing requirements. The resistance for RB1 and RB2 are set by the values chosen for VE and IB as shown in equations 3 and 4. The gain of the JFET amplifier is dependent on the input resistance of the BJT amplifier and thus must be calculated before progress is made as shown in equation 5. The desired gain of the JFET is approximately 10 volts per volt, which along with the chosen RS value of 5K allows for equation 6 to be used to find RD. For the piecewise simulations, all capacitor values were chosen to be 33 microfarads for simplicity. An open loop gain of 200 volts per volt in the preamp was desired such that when a negative feedback resistor is applied, the closed loop gain can accurately be calculated using equation 9. Equations 7 and 8 show the calculated gains for the preamplifier. The target of 200 volts per volt isn't completely satisfied, however, it's still close enough for the feedback equation to be effective. After all of our component values were calculated, we put them in the piecewise software. The graph on the top is our piecewise simulation result. It displays a gain or Vout over Vin of about 24. We then moved on to build the physical circuit. The bottom graph is the output of our signal showing a gain of 26 since our input was 100 millivolts peak to peak. These are both acceptable results and we are now ready to move on to the power amp.